timer. I've started it up and I've turned the light on here. I hope it's not too bright, but I want to zoom in here to the cell so you can see that we're starting to produce gas. You can see the extreme bubbling going on, and the gas is somewhat restricted in that I have that connector strip inside too. So what happens is it collects under the strip, forms larger bubbles, and then comes out on either side of that terminal strip. But you can see the vigorous activity going on in there. And we'll go ahead and switch this light off. I don't know, maybe we need it, maybe we don't. Anyway, we can see now, let me zoom in here, you can see the water starting to come up into the tube. We're pressurizing already. And I will show you also in the specs so that you can run Faraday's first law against it and see exactly what we have here. You can see the water rising now as the pressure is building. See the line of the water right there. So what I'm going to do is I'll cut off the tape until we get the water to about here, and then I'll come back and we'll continue on. But you can see the activity in there. And remember, this is a 2-coil system, and our water level, it has to fill up, it has to pressurize this area up here, push the oxygen out. I don't create a vacuum when I start. And then of course this small area up in here, it's filled to about this edge here, so this has to be pressurized. But once it gets that up to about 1.08 ATM, then we start flowing water. Okay, we're starting to move a little faster now. Here we're up to here, and you can see if I put my marker right here, we're starting to go pretty good. We're moving the water up there. And I make a misstatement here. This particular cell that's on this video is at 1.08 ATM. But the cell that I'm going to show you the stats on that I want you to run Faraday's law against, Faraday's first law, is running a little bit higher in pressure. The problem with this particular one is I don't want to mess with it now, but I see I don't have the lid on the displacement tank quite tight enough. We're getting some water leakage showing we're losing some of that pressure. So that's part of the reason that this is taking a little bit longer than normal to finally get to where it's producing the water there in the beaker. But let me come back again. When we get over there to the other side, I'll come back and we can start timing it. You can see the activity in here. It's very similar to what you've seen in the other videos with the open beaker. As the pressure builds up also inside the current drain, of course, for some reason, varies quite a bit, and we end up with a higher efficiency when we're operating under more pressure, which doesn't make a whole lot of sense. Okay, we're getting up there. Here's our water line again right here, and like I say, I apologize, I don't want to change it now because we've got too much time already invested in the video, but we've got a little water leak here. So I'm losing some pressure, so it's taking a little bit of time of getting up there. Okay, I'll come back here in just a second. I'm going to throw in here a picture of this power supply because the data I'm going to show you is exactly similar to this. At this point in time we're running 20 volts, 64 milliamps, and this could actually be 66 milliamps because this particular supply moves 2 milliamps at a time in its reading. So 64 to 66. So say 64 plus or minus 2. And our activity is still very vigorous. You can see it quite well there. And the proof of the pudding obviously is going to be when you run this against Faraday's first law